All right. So physical quantities and units, what do I mean by this? So if you take a look, you can see my screen. So a physical quantity is actually a quantity that can be measured. I think last week we did cover something here, but it was a very quick one. Yeah. So example would be length, mass, and then time. So in the olden days, they can't really have a very standard kind of measurement for length, right? Do you know how they measure length in the past? Any idea? No idea. You all never heard of anything about the measurements in the olden days. Okay. They use their arm. They use their, okay. How do they use their arm? For example, from here, okay, from the tip of the finger to the elbow. Okay. So they sell by this kind of measurement. So that means every arm of the cloth, I'm going to sell you how much. So how many arm length do you want? Okay, how many arm length do you want for the cloth? Then you have to pay me this much. Do you think that's fair? Do you think by arm length is fair? Not fair. Why?
Everyone has different arm lengths.
Exactly. So if I'm the boss of the shop, right? I'm going to hire somebody who has the shortest arm length to help me sell the cloth, isn't it? Okay, so by one arm length, if it's shorter already, right? Okay, so I can earn more money. From the same amount of cloth I have, well, I can probably sell 1 times the price, okay, or one times the usual. One extra lah. That means if I have 10 meters of cloth, okay, usually I only can, let's say, get $100. Now I can get 200. Because the lady that I hire has a shorter arm length. Okay, so not a fair measurement. That's why it is very important that we choose the correct, okay, apparatus to measure. All right, and then look at this one. For example, this giant pencil. Okay, it's 350.5 cm long. You see this unit here, cm. Okay, so this is like a standard measurement that we follow worldwide. Everybody, if they're talking about centimeter, it has got to be the same measurement. 1 cm is like this, means like this. It cannot be Singapore 1 cm is like this, okay? And then you go to Malaysia, your 1 cm is like this. No such thing, right? Every country will have the same one, okay? Now, so magnitude is the size of it, all right? And then unit will just be the standard measurement that we are making. It can also come in yards. It can also come in like meters, okay? There are some standard units. So internationally, we need to follow this thing called the SI unit, right? Okay, so that's how the SI unit come about. This is the original name, which I do not know how to pronounce. Okay, so let's take a look now. So the quantity that we measure are these. Length is very common, okay, and you need to know this, especially this chapter. Then mass is also something very common for you. Time, temperature, okay, and then there's also volume, etc., right? So all these has got its own standard unit, okay? So what do we measure length with, okay, or how do we actually represent the measurement for length? We go by the meters, and the symbol is small m, okay? Mass will be in kilogram, all right? So this is kg. Luminous intensity, how bright something is. Yeah, how bright it is. Okay, then you have time. Time standard units is actually in second. Temperature in Kelvin. Are you surprised? How come it's not degrees Celsius? That is not the standard SI unit we're talking about. What we use in Singapore is degrees Celsius. Okay, but actually the actual SI unit is Kelvin. K, capital K. Electric current, ampere, capital A, okay. Luminous intensity, candela, CD. How to tell how much Kelvin is 1 degree Celsius? Okay, quickly Google now and tell me the conversion. The amount of substance, now this is in mole. We represent it by MOL. You are going to learn about the mole calculation only when you do chemistry in upper level. So set 1 and 2, you don't need to know yet. Okay, there's a way to calculate. And then because I'm a chemistry major, right? Yeah, so I'm very good at calculating this. I love to do this mole ratio, mole calculation. So Anna, your sister already completed set 4. She will understand what is mole. And she might be frowning.
1 Kelvin is equals to negative 272.15 degrees Celsius.
Yes.
What?
Can you try? Now, Anna, try this thing now. 1 degree Celsius is how many Kelvin?
Okay, let's
That's
see.
easier. Okay, I come back to Anna first.
274.15. How
Yes.
big is Kelvin?
Yeah, exactly. Don't be shocked. It's like that. So Anna, okay, I can see you smiling, you know. Is it that your sister is around? No, but do you find it funny? The mole? It's not the mole on the face, okay? Every student will tell me this, huh? We calculate amount of substance by the mole on our faces, on our arm, on our body. No, okay, it's not that mole. Yeah, I will explain. Let's say we have a chance to come across a topic much later in the year, and there's a chance to explain to you. I will. Okay, don't think otherwise. I think you think too far already, but it's normal. Okay.
Oh my goodness.
Right. So these are highlighted. You know why? Because this will be very common for you in your secondary school years. Okay, so like already said, 1 degree is 274 point something Kelvin, right? Can you try 2 degrees now?
It just increases by 1.
Okay. So what does this tell you?
It tells me that it minuses off a certain
Minuses
amount.
off. So that means in order to convert from degree to Kelvin, we just take the degree and then we add something, right?
Something. Yeah.
Which is 274 point blah, 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 blah.
It's confusing me a lot.
Don't. Okay, don't. You don't need to do the conversion for degree to Kelvin, but you need to know, okay, the SI unit for temperature is Kelvin. All right? And it's so funny, right? Then you'll be thinking, just now more on the body, then now Kelvin, somebody's name. Somebody's name is actually a unit. Yeah, for temperature. Okay? Yeah, it happens. Now, so these highlighted ones are the commonly seen ones you will come across in secondary school. Okay, so they are very small and very big quantities. Okay, so choosing the correct unit, okay, whether it's meters or centimeters or millimeters, can either help you or make your life miserable. You agree? Okay, for example, bacteria is so small. Okay, we need to actually make use of the magnifying glass to see bacteria. Okay, so this is the length.
Not magnifying glass, microscope. Magnifying glass is not
very good.
Make it big enough.
Never pick it up, huh? I was hoping, I paused a little bit, hoping that somebody will point out. Then eventually unlocked it. Yes, microscope, magnifying glass. You know it's magnifying glass? The one that you hold around and then you try to find like fingerprints or something like that. Okay. When you are carrying out investigation. So it should be the microscope because bacteria is so small, it is not seen by the naked eye. Now, okay, in this manner, right, it's so difficult to represent the length of bacteria using meters. Okay, and then the sun is so far away from us. Most of the time, we might miss out writing certain number of zeros, isn't it? when you have to repeat, a lot of times students will write maybe just 40 or 50. Okay, so it is important, okay, to learn about prefixes. So you take a look at this. Have you come across this before? Never. Okay, take a screenshot. This is going to help you. Okay, so what do I mean by this? The easier one for you to see now is kilo. Remember kilogram? 1 kilogram is actually 1,000 grams, something like that. Okay. Then you look at the centi, milli. Remember I mentioned just now millimeters. Okay. Centimeters and the meter. Hi, Zixuan, where do you go?
I want to get something.
Right. So this table here, okay, this table here helps you to do conversion. For example, I ask you, okay, can
Wait
you
a
help me?
second. There's
Sorry?
a kilometer, so does it mean there's a gigameter and a megameter?
Huh? What kilometer? Again?
Kilometer.
Kilometers.
I accidentally pronounced it as kilometer. Kilometer. So is there a megameter and a gigameter?
Yeah, we can represent it that way also. If there are too many zeros, then what we can do is actually, okay, to write it in a certain way. Okay, can?
Thank you for clarifying.
Then again, look at this nanometer. These are more common that you heard of, right? So Enlek pointed out that is there such a thing as megameter? These are the prefixes. They can be used for many different types of measurement also. Okay. Now, so if I use it for gram, you also can apply kilogram, megagram, gigagram. It depends on what unit you are measuring. Can? Okay, but the most common one you need to know is like kilometers, kilogram, right? So these are actually the extra information for you. Okay, but tell yourself, very commonly asked will be the kilo, okay, and then centimeters, millimeters, micro and nano. I seldom see questions come out. Yeah. Milli is common, kilo is common. Can I move on? Zixuan, you okay, Zixuan?
Yeah.
Okay, good. Okay, so if you look at the two boxes, okay, and then compare, you can actually see that there's something similar about both of them, and there's something different. So what is the same? Same will be the volume of the box because of the dimension. Okay, the base, okay, the height, all right, the length, they are all the same. But what is different? The mass. Remember what's the definition of mass? The amount of matter in a body, right? So the amount of matter here has more, right? But here it's lesser. So we are talking about, we imagine these are the particles or the atoms. Okay, so more of it, lesser of it. Okay. Next thing, okay, quickly go to density. Okay, because mass and volume is also linked to density. Density is defined this way. It's actually the mass per unit volume. Okay, it's a derived quantity. Yeah. So in this case above, in this cases in these two boxes above, okay, box A will be said to have a higher density than box B. Why? Because density is calculated this way. Okay, can y'all take note? Density is calculated using this formula, mass divided by volume. Since A has got a greater mass. Remember I mentioned just now? But they are